Today's lesson is over solving inequalities that involve multiplication and division. And although our steps are going to still be very similar to equations, where we're going to do the opposite or the inverse operation to isolate our variable, this is one of the key places where we have to do things just a little bit different because it's an inequality, or at least sometimes. So you know that the opposite of multiplying is to divide and vice versa. So we're still going to do that opposite or inverse operation when we're solving inequalities that involve multiplication and division. What we're going to really need to pay close attention to is the sign of the value, the number that we're multiplying or dividing on both sides. And that's really the big difference. Everything else will still be very, very much like what we did with equations. So essentially, when we are multiplying or dividing each side of an inequality by the same positive, so write that down, by the same positive number, that's still going to produce an equivalent inequality. So this is basically when our constant or our multiplier is greater than 0. So this is just right here is fancy for positive. And if we decide to multiply both sides of an inequality by a positive value, for example, here we've got a positive 2 being multiplied on both sides, the inequality relationship should maintain. It should produce an equivalent relationship. So here we know that negative 6 is less than 8. We know that's true. If we multiply by 2 on both sides, we get a negative 12 on the left. That is still less than positive 16, which is the result on this side. So the inequality relationship is still preserved. Nothing happens, nothing bad happens, if you will, and we're okay. Same thing if we're dividing both sides. If we know that 6 is greater than negative 8, for example, and we choose to divide both sides by a positive 2, that still results in a positive 3 here, a negative 4 on the other side, and it is still true that 3 is still greater than negative 4. So again, that inequality relationship is still preserved. Okay, so when our multiplier is positive, if A is greater than B and C is positive, then the product of A times that constant is still going to be greater than the B times that constant. Okay, so as long as we do it on both sides, the relationship still works. And this is still true for the greater than or less than and all of those guys. Okay, so that part is really not different. So where we really need to pay really close attention is when we start dealing with negative multipliers. And that basically has everything to do with our number line and the fact that we understand, or I hope, that on the negative side, things sort of work in the opposite or the inverse. So a quote-unquote larger value on the negative scale is actually a smaller quantity than the one that's closer to 0. So for example, if I gave this some values just as an example, let's say that here is 0, and then here is 2, and then 3, 4, and that's 5, right? So we know that 2 is less than 5, 5 is greater than 2, we know that that 5 is larger. But on the negative scale, right, if we have a negative 2 and a negative 5, that negative 2 is actually a larger quantity than the negative 5. Even though it's closer to 0, it's less negative. And it's closer, it's further to the right. This is the reason why, right? This relationship is where we have to be really careful when we are multiplying or dividing by a negative in an inequality. So we know that in this inequality, if we relate A to B, we know here that A is greater than B. But in the negative side, negative A is actually less than negative B. So when those signs change, the inequality relationship is no longer the same. Okay, now let's put that into action here in an example so we can summarize this formula or this result. So let's go back to our original example here. We have negative 6. We know that is less than 8, and that's fine. Now let's say that we decide to multiply this time by a negative 2 on both sides. The result on the left would be a positive 12. And the result on the right would be a negative 16. Now, originally we had agreed negative 6 is less than 8, and that is fine. But now, is this left side still less than the right side? Is positive 12 still less than negative 16? The answer is no, right? We know that really positive 12 is now greater than negative 16. So we can see how multiplying by that negative forced us to switch or flip our inequality. And this is review, but I know it's been a while, so I want to just make sure everybody understands why we flip the inequality when we multiply or divide by a negative number. And you can see it again here. You've got that 6 is greater than negative 8. We know that's true. If we decide to divide both sides by a negative 2, the resultant inequality is no longer a greater than. Negative 3 is not greater than 4. It is less than. So again, multiplying or dividing by a negative causes the relationship to change, and that makes us have to make sure that we flip the inequality so that the statement is actually still true. Okay, so for the statement to still work, we have to flip that inequality. And that's really at the heart of what's different about today's lesson. Okay, really it's when we're multiplying or dividing in an inequality by a value that is negative or less than 0. So when multiplying or dividing each side of an inequality by the same negative number, the direction of your inequality, the direction of the inequality symbol must be flipped or reversed. Reversed is really probably the proper, but we say flipped a lot. Okay, in order to produce an equivalent inequality. Okay. So, for example, if A is greater than B and C is negative, then the product of A times C will now be less than the product of B times C. Okay, so the big idea, if you want to walk away with what is like the big difference today, or the main thing that I want to remember, is when you're multiplying or dividing by a negative, you've got to flip that sign, right? Write it down. Remember, if I write it down, you write it down. So flip that sign when multiplying or dividing by a negative. All right. Really, other than that, everything else we're going to do is exactly the same as what we were doing with with equations and so forth. Really, of course, we'll still usually graph our solution, but other than that, the rest of the steps are the same. So let's go ahead and start practicing a few of these. Let's take a look at number 1. So we want to solve the inequality and then graph our solution. On this one, I want to identify where my variable is, look at what they did to it, and then we're going to do the opposite or the inverse. So it looks like they multiplied by a positive 6. So the opposite of multiplication is to divide. So we're just going to divide by that same positive 6. Now that is a positive, so I don't have to worry about doing anything different or odd with my symbol. It can stay exactly the way it is. We'll divide by 6 on both sides. That'll cancel our 6 here. On the left side, it'll leave x alone. Our inequality relationships remains the same, so it's still going to be a less than. And on the right side, negative 30 divided by 6 is a negative 5. So our solution is all the x's that are less than negative 5. And then we graph our solution. And just for fun, I'm just going to do this a couple of times just to review that interval notation that we talked about. You could also write, express this with interval notation, graph, or the inequality. So if I want all the x's that are less than negative 5, that means that they're going all the way from negative infinity up to negative 5. It never includes infinity, and in this case, it also does not include the negative 5 boundary. So that would be the interval notation expression of that solution set. Everything from negative infinity all the way up to negative 5. Okay, but let's go ahead and graph it as well. Okay. Now I'm pretty flexible on the graphing. You can decide where you want to put your 0. You don't necessarily have to put every number. But when there's 0 here, 1, 2, 3, 4, 5. So here is negative 5 right here. And when we look, it's going to be it's going to be an open circle because it doesn't have the little or equal to bar. So there's my open circle. And I want everything less than, so it's going to be all of these values to the left, just like that. Okay, and we're done with that one. No worries about the inequality because we divided by a positive number. So really nothing had to change or be different. Okay, let's take a look at number 2. Number 2, our variable is on the right. And so this is what I want to get rid of here. And when we're doing that, since they're multiplying by a fraction, we know that even though the opposite of multiplication is division, when involving a fraction, we actually end up not dividing, but rather multiplying by the reciprocal. So the way I'm going to eliminate this fraction that they multiplied f by is by doing the reciprocal of it. And if I do that on one side, y'all know the drill. Do it on the other. You got this, right? And then these guys all cancel. That leaves me with f by itself. That's a positive fraction, so I don't have to worry about my inequality symbol, reversing it in any way. And then let's find out what we get here. You can either multiply the top and the bottom and then reduce, or sometimes you can tell that we are reducing first, and that makes the math a little bit. So in this case, that's what I'm going to do. I'm going to cross reduce. I can see that 7 over 7 would cancel, like that. And then I know that 6 over 3 is 2 over 1. So you could do that. Like I said, you could just multiply it out, or you could cross reduce first. If I can say, 7 goes into itself once, those cancel out. And then 3 goes into itself once and into 6 twice. And so we really end up with a negative, because that was a positive times a negative, 2 over 1, or just 2. If that doesn't feel comfortable, feel free to have done it the other way. So just to kind of do a little side work here. You've got, this was our original. You could have multiplied straight across. You would get 42 on the top. You'd get 21 on the bottom. It would still be negative, but 42 over 21 is exactly 2. So you'll get the same answer both ways. More importantly, the next most important thing here is to rotate this whole statement so that our f, or our variable, is on the left. So this is very hard to read. We've talked about that. This is different than just reversing the sign. We didn't have to reverse the sign because we did not multiply by a negative, right? So I'm not going to reverse the sign itself. But at this point, now that I'm done, I am going to reverse the entire statement. And since it's the whole statement, it doesn't actually reverse just the sign. The relationship is still the same. But let's see, it's still opening toward the f, pointing toward the negative 2. I just rotated the whole statement. But this makes it so much easier for us to graph now. We want all the f's that are greater than or equal to negative 2. So again, at this point, I can put my 0 here, maybe my negative 2 right there. This does include negative 2 because of my little or equal, so I'm going to fill that in. Really nice and obvious, just like that. And I want everything greater than, so to the right. So there's my graph. Okay, doesn't have to be super complex, it just has to denote the values. Okay, all right. So let's try number 3 now, because this is where the game does change a little bit, right? So number 3 is very similar to number 1. We want our variable isolated. They've multiplied by negative 4. So we're going to do the opposite, or the inverse, which is to divide. But this time we're dividing by a negative. In order to do this correctly, we have to divide by a negative 4 on both sides. That's the big difference between an example like number 1, where the 6 was positive, so we didn't have to worry about any reversing of or flipping of our inequality. But now that we are dividing by a negative, in order for this to still be a true statement, when we simplify, now it's going to have to be m is not greater than or equal to, but rather less than. We have to flip our inequality or reverse the sign, and then we can write our answer. And this is still a positive 4. Okay, so this is one of those where we have to flip that sign because we divided by a negative on both sides. And now we say, okay, well, our solution is all the m's that are less than or equal to 4. So maybe I'll put my 0 right here. 1, 2, 3, 4 would be right there. This would be a closed circle because it includes 4. And I want everything less than 4, so to the left, just like that. Okay. Let's try number 4. So on number 4, they are dividing our variable. Our variable's right here. They're dividing by a negative 6. So the opposite of dividing by a negative 6 is to multiply by a negative 6. And if we do that on one side, we do it on the other. Okay. This cancels out, which is great. we get x's, but this time, since we multiplied by a negative, it's not going to be greater than. Now x is going to be less than. So there we are, once again, flipping that inequality. And on this side, we're going to do 1/3 times -6. Remember, when I'm doing a whole number times a fraction, I multiply by the top, divide by the bottom. So -6 times 1 is still -6. -6 divided by 3 is -2. And the x is on the correct side here, so I don't have to worry about that. Okay, I want all the x's that are less than -2, so maybe I'll put -2 right here. This is an open circle. There's no little bar underneath. It's not or equal to, so it doesn't include -2. And I want all the x's that are less than, so that is in this direction. Okay. Go ahead and try number 5. Actually, let's do number 5 together. Let's do number 5. I'll have y'all try number 6. Let's try number 5 together. Number 5 states that our, first of all, our variables over here. And by the way, I want to mention something. If you like to put the variable on the left at the beginning, you're welcome to do that. So in this example, I'll do that to show you. Instead of waiting until the end, you could do it right here at the beginning. You could start off and look at this inequality, and as soon as you notice that the variable is on the wrong side, you could rotate it before you begin. And again, when you're rotating it, you're rotating the entire statement. We're not flipping the inequality, we're rotating the entire sentence around. So I really haven't changed anything about this relationship. I've just taken the whole thing and turned it around, okay? Notice it's still opening toward that -4x, it's still pointing toward the fraction. So I haven't done any of that damage. But now I've got the variable on the correct side, and sometimes we like to do that first, okay? And you are welcome to do it. And then we can start talking about how we're going to solve for x. The opposite of multiplying by a -4 is to divide by a -4. So we'll do that there. On the other side, I'm going to divide by a -4, but remember that when I divide, when I'm dealing with fractions, I don't actually ever divide. Instead, we multiply by the reciprocal. So on this side, when I consider, oh, I've got this -2/3, and I'm dividing by -4, instead of dividing by -4, we are going to multiply by the reciprocal. Okay, so we're going to not do this. Instead, we're going to multiply by that 1/4. So we're going to multiply those guys together like that. Okay, and when negative times a negative is a positive, 1 times 2 on the top is still a 2. On the bottom, I've got 3 times 4, which is a 12. And that does reduce to 1/6. So our inequality is all the x's that are this time less than. I had to flip my inequality symbol because I divided by a negative on both sides. So I do have to flip my inequality. X is by itself. It is now less than. And then when I multiplied my fractions together here after flipping or doing the reciprocal, I get just 1/6. Okay. And so that is my final inequality solution. And just remember, pretty soon we'll be using calculators, so if that stresses you out a little bit, I want you to practice it, but it won't be the end of the world if you, at the end, you just reach for your calculator. We'll be doing that pretty soon. Okay, and this is, I'm not going to worry too much about, just find, 0 can be here, that's your 1/6. Sure, what's important is that you understand that this is going to be an open circle on that 1/6, and you want everything less than that value, so it's to the left. All right, I want you guys to try number 6. Try that one on your own, see how that one goes, and then we'll check it. Okay, so let's check your answer here. So if we multiply by the reciprocal on both sides, our x is in the correct place, but we've got to get rid of this fraction, so we multiply by its reciprocal. That's going to eliminate the whole fraction. We'll have x. Since we multiplied by a negative, did you remember to flip your inequality? That's the big thing, right? Flip your inequality so that now x is less than or equal to this result. Okay, so hopefully you remembered that. And then a negative times a negative is a positive, and 2 times 5 is 10. 10 divided by 4 does not divide nicely, but it does reduce. So really the best answer is if we then reduce that fraction and we get 5/2. You could also say 2.5 if you'd like. and then we can graph that. And we flipped our inequality, so all is still good in the world. So we've got 0 here, 1, 2, so 2.5 would be about right here, or 5/2. This is a closed circle on that, since it does equal, and it's all the x's that are less than. All right, let's finish out with just a word problem here, and then the rest we'll do in class. So let's take a look at number 7. It says there are at most 36 blue and red marbles in a bag. There are at most 36, so that's the most there are. That means less than or equal to. That's the most. We wouldn't want any more than that. The number of red marbles is twice the number of blue marbles. Write and solve an inequality that represents the greatest number of red marbles in the bag. Okay, so we know that, like, for example, we don't know anything about the blue marbles. So we'll call that B. But when it comes to the red marbles, we know that there are twice as many as blue. So whatever the red number is, it is twice whatever the blue is. Remember, we like to be able to write, even though there's different quantities, in terms of the same variable. So we know nothing about the blue, but we know the red is twice as many as the blue. So this can be my variable for blue. This could be my expression here, variable for red. And we know that together, the blue plus the red, okay, has to be at most, which means less than or equal to 36. Okay. So this is my blue marbles plus my red have to be less than or equal to 36 because it says at most 36. But instead of using like a B and an R, since they told us that the number of red is twice the number of blue, we can use the same variable for that. So there's our inequality, and this does simplify because we've got a little bit of a like term here. So the blue plus the B plus the 2B really simplifies to 3B. And this is the first part of this write the inequality. So this is our inequality that represents that situation. And then it does ask us to solve. So now let's go ahead and solve here. If this is our inequality, we're going to get B alone by dividing on both sides by the 3. And that tells us that the number of blue beads must be less than or equal to 12. Okay. Now I did say write and solve the inequality represents the greatest number of red marbles in the bag. So now we know that the blue is less than or equal to 12, but we know the red is twice that. So if now we take, so for the red, it would be that guy right there, but times 2. So if there is less than or equal to 12 marbles that are blue, then 2B, which is the red, must be less than or equal to 24. Okay, and that is what the red represented. Okay, so the greatest number of red marbles in the bag would be 24. That would be the greatest amount. It would be less than or equal to that. Okay, so the greatest, because it told us it was twice the number of blue. So once we found that blue was 12, we just do twice that. So the greatest number of red is 24. That would be the greatest amount. Okay. All right. That is our notes for today. We will take care of that last one when we're in class together. Have a great day.